Hello everyone. In this video, we're gonna discuss how does the computers really turn on. So you might have pressed the power button on your computer thousands of times, right? But do you actually know what happens in those first few seconds before you even see the desktop logo or anything, like even before the mouse appears? Like the CPU has just woke up. It has no idea what the hardware it is connected to. It doesn't know about your SSD, your RAM, your GPU, nothing. So how do you think it goes from complete darkness to fully running an operating system? That's exactly what we're going to cover in this video in today. So I'm not just going to explain it theoretically. I have actually built a bootloader from scratch and implemented, if you know, global descriptor table in protected mode and in 64-bit mode, and also I managed to make page table, which is really simple. So in this video, in this series, we are going to do that. And by the end of this video, you will understand what bootloader is and what happens before bootloader, so we can get the context of like the background that we will need eventually while writing the bootloader. And uh, and you will also understand why every operating system that you have used, including like Linux, Windows or Mac OS, or even Raspberry Pi, depends on the bootloader. So let's get started into it. So let's jump to next slide first. So what do you think whenever you turn on your PC, you press the power button, right? So whenever you press the power button, it sends a power signal to PSU. PSU stands for power supply unit, and the power supply units getting that signal sends a stable voltage to a motherboard, and motherboard has CPU, so it turns on the CPU. So on the right section, I have also shown you the motherboard. Here, motherboard is like is its name stand for, it is the mother of the computer. Like it has a really important uh, it has really important role in turning on the computer and managing the computer hardware. So you can see that it has CPU, it has RAM, it has BIOS chip that we will eventually use, that and the power IC and charging IC, the clock for frequency, the controller, and everything. Okay. So after the power supply unit gives stable voltage to motherboard, it basically turns on every hardware, including a CPU. Okay, and the chipset hardware maps a small memory, that is 1 MB of memory, that gets instantly mapped. That means we don't need any software to power it up. And after that, that means, what does that mean? That means that we have some memory that we can use even after just turning on the PC. Okay, that is already built by your motherboard hardware, so you don't have to worry about it. So after that, after CPU has turned on, it jumps to a reset vector. So what does reset vector mean? It is an address which is at the top of the 4 GB of memory, and it will eventually has a address of BIOS, which CPU will jump eventually. So that's it for this slide. So let's go to next slide. Okay. So as I have already told, the CPU wakes up and it jumps to reset vector, and this is the long address. It is at the top of the 4 GB address space, and the CPU starts here. And also one thing that you can ask is that, is I have told you that I told you that we have only 1 MB of memory space, but how can we address this long? This is like, I think this is 32 bits of memory that needs to be addressed. So how can we reach this address with just 16 bits? So I don't know much about it, but I know for sure that computer hardware use some kind of trick uh, to expand its base for memory, and then eventually it can reach this address. Okay, so that's it. Also, uh, computer normally before running BIOS, it's in like the special state that it can address this address space, right? But after it has jumped to BIOS, the computer is in 16-bit real mode, and it is the mode that CPU usually used to run in from the Intel chips like IBM computers, that like old computers from 1978 or 90s computer, you know what I'm trying to say. So here the CPU starts here, okay, after this reset vector, and reset vector leads to BIOS. So and BIOS, in BIOS the CPU converts into real mode. So you might be wondering, what is real mode? Like normally when we are doing any activity on your PC, like I'm explaining the video in my PC, or like suppose if I'm watching a YouTube video, I'm playing a game, I'm editing a video. So at that time your PC is basically running in a long mode. That means 64-bit mode, means it uses 64 bits data and address bus to address everything. But uh, there is a sequence of mode that the CPU has to go to reach this long mode. Okay, first of all the CPU has to go to real mode that I have recently explained, which is 16-bit. Then it has to reach the protected mode, where we will enable paging and everything, and that is 32-bit mode. And then eventually we will load the uh, we will reach the 64-bit mode, that means long mode. Okay, so in this real mode, we use 16 bits for everything. So that means we use AX, BX, and CX register for memory addressing and data addressing. But you might be thinking like we have 16 bits. That means we can only address memory up to 2 to the power of 16. That means 64 kilobytes of memory. But I told you that we have 1 MB of memory. Same also here. We use so memory is divided into segments and base address. So to address any memory, we will add segment name number plus base address. We will eventually help us to address memory up to 1 MB. So as I have already told you, so this 1 MB is hardwired for real mode by the motherboard chipsets and exists instantly when you power up. So no software sets it up. Okay, also, in this 1 MB, different regions are mapped to different address space. Like some regions are mapped for GPU and some are used for BIOS flash. You will see that in next slide. So let me show you the next slide. Okay. So you can see I have put a diagram of 1 MB memory mapping. So you can see that from this address from 0 kilobytes to this 512 kilobytes, that is for BIOS mainly. Okay, and this is the usable memory from 0500 to 7FFFF. That is the memory that we will use to write our bootloader, also load our first sector of our kernel, 512 bytes of kernel in this address space. Because I told you that from this address, from 8 of and 4 zeros to this address, it is for GPU. Like you can see that video memory, color video memory, this is used by the GPU. And after that this from this C000 to FFF, that is the top of the memory, that is used by the BIOS. Okay, so that's it for the real mode. Also, I think I forgot to mention. So also there is so you might be wondering like why there is only 1 MB. Like whenever I buy a PC, it says like it has 8 GB of RAM. So what I'm trying to say is that your CPU is in a special mode that it sees only 1 MB. So that means the other memory is invisible to CPU in that mode. So to get to other memory, you have to change the mode to like protected mode or long mode, so that you can address even longer space. Okay. So that's it. So we are at BIOS, right? And we are in real mode. So here, this is slide for the BIOS. Okay. So after BIOS takes over, so BIOS does a series of tests called post test, power on self test. It checks for RAM, keyboard, GPU, and like it reports. Like I don't know if you have got these beep codes or not, but in my uh, school days, there used to be really old computer, and if there was any hardware failures, there used to be beep codes that is generated by the BIOS to tell the user that there is something wrong in the hardware. So okay, so what is BIOS? BIOS stands for basic input output stream, and it is a firmware. That means it is hard coded in the motherboard. So whenever we turn on PC, CPU jumps to BIOS address, and it the BIOS runs. Okay, the main function, as I have already told you, is for the BIOS is to detect RAM and SSD, and also it provides some of the function that we will need, some of the interrupt, or you can so call it function that we will use in the bootloader. So normally first BIOS checks if hardware is working by post, and then like it will mm, say like uh, it will basically help us determine if CPU is working well, if keyboard is working well, and then it detects them and then initializes them before, and then BIOS provides interrupt that I have already told you, and then it calls bootloader, and it provides some important function for the bootloader. And also one thing I want to tell you for the users is that writing a BIOS is really difficult. Okay, so if you have like imagine just like I thought previously, like I will write a BIOS, but writing a BIOS is very difficult to compared to writing a bootloader, because nothing is initialized, like there is no foundation that you can step in. You have to build everything. You have to learn RAM initialization, chipset programming, and much more. Like it is much too level. Like I am not currently in that level, so I cannot explain much. Okay, so after BIOS uh, it initializes everything. Okay, so after it does everything, so it let's first of all let's go to next slide. So it looks for a booting device. So after post check, and it scans for a boot order. That means a boot order is a sequence of like device. It the BIOS checks, and it looks for a signature of 0xAA55 in the last 510 and 511 bytes of the memory, so it can identify it, and it's like it can tell that this is a bootloader and this is the program that I need to run next. Okay, so I have made the slide. So firstly it select boot device. That means BIOS checks each device in order until it finds a valid boot signature, and the boot signature is 0xAA. This is in little Indian form, so this is looking like that means the least significant bit is in the first, so that's why it is first it is 55 and then it is AA. But the normal in memory we can the it is stored in AA and 55 format. Okay, so it goes to every device and checks the magic signature, that is this signature, and if the signature matches, it will load the first 500 bytes of that thing to the 7C00 address. So this was the address. Okay, so bootloader, as you can see, 7C00, this is the address in 1 MB of mapping that we will load our bootloader. Okay, and then we will jump to this address to execute the bootloader. Okay. Okay, this slide is like not that important. I have already discussed about it. So this this slide basically tells what bootloader code consists of. So firstly, it will have some assembly instruction, that is the like main bootloader program. So and after that, if we have any space left, then we will pad that space with a bunch of zeros, so that computer like the CPU doesn't execute that data is something. Okay, and at the last that is at the byte 510 and 511, that is the last of that 512 bytes, we will write a magic signature so that the BIOS can know that this is a bootloader. Okay, so bootloader. So our task. Okay, this is our task. This is our code, and so in this series we will write every single byte by byte code of bootloader in sorry, in assembly. So we will write x86 assembly, and we will assemble it, and we will also load it in disk. So first, we will load the bootloader, and then we will also make a small kernel that like basically prints something on the screen. So it is not that difficult to, like, it is also, kernel is also program, right? So it's not difficult to make a program and name it is like kernel and simulate like how operating system works. So also, what it must do, so our bootloader should be able to switch the CPU from 16-bit mode to 32-bit mode in protected mode, and then implement global descriptor table and paging for virtual memory, and then switch to 64-bit long mode. And in 64-bit long mode, it will eventually jump to kernel and operating system will take the charge. Okay, so in the next video, we will set up the development environment, and we will write so first our first bootloader program, and then that's it. Then we will test something. Okay, that's it for this video. I hope you guys really enjoyed it and learned something new in this video.